Hello everyone, this is Dr. Neeraj Khairwal. I'm working as Head of R&D at Layer 1X. Today we are starting with a new series of smart contracts which support interoperability. For this, we have this Xtalk feature with L1X blockchain network which supports cross-chain communication across EVM as well as non-EVM compatible chains. So as a part of this series, we'll start with building your first XCDP EVM contract. So in the sense, we are creating smart contracts to have cross-chain communication among EVM compatible chains. In the sense, your source and destination both are EVM compatible chains, and this XCDP actually stands for cross-chain data and message passing. So we'll be actually passing message across the EVM compatible chain. So as a part of this, let me invite Mohammed, who is working as the Xtalk team lead with Layer 1X. So let me take him into this call. Hello, Mohammed. Welcome to the YouTube series for Xtalk.
Hello, Niraj.
Okay, so today we are going to start with the first smart contract for the Xtalk, that is XCDP EVM to EVM, message passing across EVM compatible chains. So since you are leading the Xtalk team, I would request you if you could just introduce the concept of Xtalk to our audience.
Yeah, sure, it's my pleasure. Okay, I'll just share my screen now. Thank you for this nice introduction, by the way.
Thanks.
Okay, so please ping me when you can see my screen.
Yes, I can see your screen.
Okay, so basically here we're just having this demo to show that how you can just send a message from any EVM compatible chain to any other EVM compatible chain. Here we're just using Sepolia and BSC testnet. We have a function which is called L1X send, or just sending some message to another function which is called L1X receive on PSC. We are doing that through Xtalk node and L1X smart contract, which is the flow contract. The flow contract is responsible for, in this particular example, we have implemented it in a way that it will just be responsible for storing the event, which is whatever we are just sending from Sepolia, and generating the payload for the BSC testnet. Okay, let me now just go through the code and just tell you all of this. So
this is Solidity smart contract, right?
Of course, this is a Solidity smart contract. We have this standard event. The event should always be identical to this one. For this one, we are just having the message destination network, which will just be nothing but PSC, and destination contract address, which is our smart contract address on PSC, which we will just be executing L1X receive.
Okay.
We have the message L1X send, where we're just emitting our standard event with the message, which were just taken as an input parameter for this function.
Okay.
After encoding it using API encode. So for this one, the message bytes, it's nothing but the encoded version of our message, which we're just adding.
Fine.
And this L1X receive function, for the L1X receive function, it is the function which we will just be hitting on PSC chain.
Okay. So destination network would receive the message.
Yes, exactly, on a function which is called L1X receive.
Fine.
To fulfill this, we will just be deploying this smart contract on Sepolia. The same exact smart contract will just be deployed on PSC.
Okay.
And we need the flow contract. The flow contract is L1X contract, which we are just deploying on L1X, where our Xtalk node will just be hitting this smart contract to store our event and generate our payload for PSC. So for this one, we are just having function which is called save event data. Save event data should always be the same.
Okay.
For the same exact name with the same exact input parameters. So the function signature should be identical to this one. And here we are just parsing we are just decoding our message, which we have just encoded using API on the Sepolia.
Fine.
Here we are just retrieving our message And then we're just storing all of this event into our smart contract for reference. And then we're just generating the payload, which will just be the payload for PSC. Here we're just generating the payload for the function which is called L1X receive, which will just take two input parameters. First one will just be the global transaction ID. Second one will just be our message encoded, because basically we need to send the message encoded.
Okay.
So whenever we're just having this message, we're just getting the payload, and then we're just emitting an event from our flow contract.
Fine.
So that Xtalk node will just listen to this particular event and make the call to whatever we have picked as destination network on our destination contract address.
Fine.
For the Xtalk node to be able to listen to our event on Sepolia, we need to register our smart contract on Sepolia. We need to register the topic, which is identifier for our event, and we need to specify what is the flow contract for us on L1X. Here you can just register it. And one last thing which just worth mentioning, that we need to protect our L1X receive function so that no one can call it unless it is L1X. And we're doing this by just making sure that the gateway is the only authority who can just go and execute this transaction on the destination engine. The gateway, we have gateway of Sepolia, we have the gateway of PSC, and we will just have a gateway for each supported network Xtalk is supporting. So
Okay.
this was a very short brief on how we can just do all of this.
Okay, so in short, can I summarize that the role of the Xtalk node is to listen to the events that are coming from the registered chain and then convert the payload to the destination format and send it to the destination network.
Exactly, yes.
Fine, okay. Thank you so much, Mohammed, for explaining the complex concepts related to the Xtalk node and its implementation as well. Thank you so much, Mohammed. It was pleasure to have you here.
Yeah, thank you for your time. Thank you. Yeah.
Let us start with implementing the Solidity contract. So, as we have seen, we are taking Sepolia as the source network and BSC testnet as the destination network. So, we need to deploy this Solidity contract on Sepolia as well as BSC. So, for this purpose, I'll be using Hardhat for deploying this smart contract. So for that purpose, what I'm doing is I'm going to my L1X Git book to the section L1X EVM SDK to check the prerequisites. I'm going for the hard hat installation that we would need for this EVM smart contract. So let us start with this. First of all, I'll make a directory and say give it the name EVM XCDP. Okay. Next, we will check for the node version because node should be installed on this. So we have version 12 as such. We will install NVM version 18. I'll copy this command. It is already installed and we are using this version. Okay, fine, good. Next step for hard hat installation, we need to make a directory. Okay, so we will make a directory for this mkdir EVM for XCDP. This is done. We will traverse to this. This is done. Now I'll do npm init. Oh, this is done. Next comes this command to install hardhat and set up the project. So we'll copy this to install hardhat. Once this is done, we'll move on to set up the hardhat project. I'll copy this command. So we'll be creating a TypeScript project as such and following the process to install the project's dependencies. So let us select the TypeScript project. We'll click enter, yes, yes, and let these dependencies get installed. Now we will start with installing the necessary plugins and dependencies. So we'll start with the first one. Next we have is to install the OpenZeppelin contracts. Since the contracts that we are using now for this scenario don't use OpenZeppelin, we won't be installing these dependencies. After that, we are going for installing of ethers and hardhat ethers. So for this purpose, I'll simply copy the command, add it here, and let this get installed. After which comes the process for tsconfig file as such and writing your smart contract. So let us move on to our program which we need to have. Now if you notice one thing, we have mentioned that we need to replace the destination xtalk gateway contact address with the one that is here with the actual gateway contact address. So for this purpose, what we would do is we would refer to the we will first copy this code and okay, so this installation is done. We will I'll do what, I'll just go back and open it in code so that we'll be easily able to update the smart contacts and other configuration files that are required. Okay, and in the meantime let us move back to the EVM-XCDP folder. So this is okay. So here let us see what has been created. We have all these folders available. We'll go to contracts first, this log.json file, and replace this default file with the smart contact that we have. Okay, now in this, if we notice, we are required to replace this value. Okay, so I'll go to the table here. Okay, so this is the address. I need to mention the destination gateway contact address. So as we have seen, Sepolia is the source network and BSC testnet is the destination network for the scenario that we are testing. So that is the reason I'll be copying this. That is the xtalk gateway contact address for BSC testnet. Okay, and I'll add it here. So this is done. Next, I'll rename this file to XCDP core. Okay, so this is done. Now coming back to the process, deploying the Solidity contact. So we have scripts deploy.js. I'll copy this, and if you notice we don't have scripts, so what I can do is I can simply go here and add a folder scripts. This is done. Inside this we can add the file deploy.js. This is done, and add the code here, right? So this seems to be okay. Next comes is the hardhat configuration JS file. So we'll copy this command. Now if you notice, we are required to mention the private key because the scenario that we are taking here is for the demonstration purpose, for the ease of understanding, and we are passing the private keys for the BSC testnet and Sepolia. Since I am using the same MetaMask account for these two, my private keys are same and we are using only one variable. In case you have different, add the private keys accordingly. So we will go to hardhat config file, replace this, okay, and I'll need to put my private key here. So I'll remove this, and as we had this list of wallets, we have also got list of wallets for the other network. So I'm referring to this where I'm required to get the private key and add it in the hardhat configuration file here, which will be used for connecting to these networks. So this is done. So now we can go for the deployment of the contracts. For this purpose, I'm again going back to our hardhat installation file, after which we are required to compile the project first. So I'll copy this command from here and try to compile our smart contract. So the smart contract has got compiled successfully. Next step is to deploy. So for deployment purpose, we have made these changes. So we need to run using this, where our network would be the one where we want to deploy, right? So I'll simply copy this command, put it here, and okay, just change the testnet. First, let us deploy onto Sepolia because it is the same smart contract having the functionality for both source as well as destination. We will be installing this smart contract in both the test networks. Okay, so one thing that we missed on to is that here we have saved the file as deploy.js. So we are just required to make this correction and run it now. So the contract has got deployed to Sepolia, and this is the deployed contact address. So let us copy and save this contact address for further use. So I just created a template where we would need the deployed contact address at the Sepolia. Similarly, what we would do is we would run this command to store it on BSC testnet. In the meantime, what we can do is we can go to Sepolia Explorer. Okay. And here we can enter the deployed contact address and just check for it. So this will give us a validity that the contract has got deployed. So yes, we are able to see these details of the contract creation that we have done from the wallet that we are using. Okay, so this is done. Okay, so let us get it installed on BSC as well, and we'll be able to see the deployed contact address details on BSC testnet as well. Okay, so the contract has got deployed on BSC as well. So we'll copy this. First of all, save it for our further use, and then we can go to BSC Explorer and check it there as well. So I'm giving this deployed contact address. And yes, if you notice, we are able to see the contact creation through the wallet that we are using. So this is done in the sense we have got the smart contract deployed on source as well as destination. So let us move on to the next step. In case you are new to L1X, I would suggest you referring to our playlist which is for L1X VM smart contracts, where you can easily notice what are the steps to set up the L1X environment and create the L1X projects, how to build the project, deploy the project, initialize the project, and follow the entire process. So that will make the things easier for you. You can go and watch the videos. You will be able to find the link in the description for it. So here we will start with creating a new project. So prior to that, if we are required to check the dependencies, what we can do is we can just go to our previous link, L1X native SDK for L1X VM, and I'll go to my setup environment and prerequisites. So I'll just check my Rust version. Okay, I have that node version. Okay, so this is also good. Moreover, what else is required? We are required to use NVM version 18. So we'll ensure that as well. We had done that, right? So this is okay for us to go with this. So I want to create a Cargo L1X project XCDP. I'll name it to say L1X XCDP. Okay. So first of all, I'll come out of this EVM XCDP and I'll run the command here to say name the folder as L1X XCDP. So this has been created. So I can check it here. This has been created. We have the lib.rs file here. So the process that we have been following, I'll copy this code and I will delete the default code that we have with this one. So this is done. So this is done. Next we move on to the cargo toml file. So we'll copy it, go here and then add it here. So this is done. So what we have done is we have replaced the default lib.rs and cargo toml file with the ones that we have here. Next we'll go for cargo build. Okay, first of all we need to go to this folder actually. Yes, and then we'll go for the cargo build. So as we have seen in our previous videos, once we do cargo L1X build, we actually get the object file of the deployed of the smart contract that we have compiled, and after that what we are required to do is we are required to deploy the smart contract. Now for this purpose, as we have already seen in our previous video, we need to have a wallet to deploy, and for this purpose either you can create new wallet or import the wallet that you would already have by using the private key. So for this purpose, what I'm going to do is I'm going to use my existing wallet which we have built on L1X, and in case you don't have, you can create a wallet, get the faucets on it. We need to have faucets in our wallet to deploy the project. So I'll copy this command. So I'll move on to command prompt. Here the object file has been created. So to import the wallet, I'll ensure that we are using NVM version 18, and then we'll import the wallet. So for that purpose, I'll copy this command and then add it here. Replace this with the private key that we have for L1X. So I'll be using the private key of super. If you have seen my previous video, we had used the wallet private key of super for our L1X contacts as such. So let us import this wallet. This is done. So at this point, we will get this to deploy. So I'll copy this and paste it here. Now for this, what we need to ensure is, since we are using testnet here, I'll remove this angular brackets and give path to the object file. So the path is, we are here in L1X HTTP. We need to go to target L1X and then release. We have this xcdp core.o object file. So we will give the path accordingly. So deploy, and then we give target. We'll start with dot slash that we are referring to the present directory. Target L1X release, and then the file xcdp underscore core.o. Right, this is the one. We can check it here as well. Right, and then we'll try to deploy it. Okay, so let us deploy it. So the contact has got deployed. Now we will go for initialization of the smart contract. For this purpose, we'll copy this command, paste it here, and as we know the process, we will remove this angular brackets. These are not required as such, isn't it? And we need to put our contact address in the search deployed contact address here, which is this one. So I'll simply copy it and add it here and initialize the smart contract that we have. So once initialized, this is ready, right? L1X flow contract. So it has got initialized. We will copy and save this initialized contact address. And okay, so we have initialized the contact. This is done. Now the next step that we have is to register the client chain and xtalk contacts with the xtalk node. So here what we are going to do is, we are required to register our source chain contract and the L1X flow contact that we have deployed, register both of them to the xtalk node. So if we just run through the command that is there, so here if you notice, we are required to give the source registry instance address. So what is the source registry instance address? Is nothing but a source registry on which these details of the source chain and the L1X flow contact would get registered. So this is provided in below example. So this is the example we have, and this is the source registry instance address we have. Apart from that, what are we required to do is, we have to register new source. Okay, and what are the arguments that we pass? So for that, we have this xtalk contact address. So we actually name it to destination contact address, and then we pass our flow contact address, that is nothing but our L1X contact address. Next comes the source contact address. So this source contact address is our EVM address on source chain, which is nothing but the deployed contact address on Sepolia network. So source chain in this case would be Sepolia, and the event filters. So we are required to give the topic of the event. So topic of the event is actually based on the message that you send, a combination of all these details as such that we have in the contract as such. Yes, it's actually a combination of these details that we want to send. So since we have not changed anything among this, so we will be using the same topic that we have. Okay, so coming here, so this is the topic of the event. We have it in the sample present here, and your flow contact address we know, right? It is the extract address and the endpoint that we need to give. So for the purpose of simplicity, what I would do is I would copy this command actually and replace the details with the contact address that we have. So I'll copy this for the ease of simplicity, put it here. Okay, and then just update the details. So one by one, as the practice that we have been following, we will first start with the start of the command as such so that we don't miss on anything. So this is the source registry address. So this is absolutely fine, right? No changes are required here. Then we are calling register new source destination contract address. So this is actually our L1X flow contract address. Why are we putting L1X flow contact address and not BSC deployed contact address in the destination contact address in this command? The reason being, from the source network Sepolia, the message or the event would be sent to the Xtalk node on the L1X blockchain network. So that is the reason in this context, the destination contact address should be of the L1X flow contract. Okay, so what we would do is here we will put this L1X initialized contact address, copy it, add it here. This is done. Next comes source contact address. So as we know, this is Sepolia contact address. One important point to note is this description that we have written. So for this is the contact address you want to listen to, and the important thing is it should be without 0x. So the reason being, we are unifying the contract address that we are registering, and we have without 0x in L1X for smart contract initialization. So we are following the same format. So what I would do is I would go here, get the Sepolia contact address. I won't copy this 0x part, start from here until the end. So I'm copying it and I will replace the existing one. I'll add it here. This is done. Source chain is Sepolia. I don't need to change it. Event filter is same, right? So I'm not changing any message related to it. That is the topic. And now let us try to register our details onto the Xtalk node. Okay. So once these details of the client chain and Xtalk contact is registered, then we need to validate that our data has been registered. So we have got the command for this as well. Let us copy this and let us go here. So yes, the contact function is called successfully. Seems it should have got registered. So let us try to check it. Definitely we need to update the, okay, there seems to be some issue. What I would do is for the sake of simplicity, I'll copy it and put it here and just let us replace the variables required. So this is source registry instance address. I'll delete this and get the source registry instance address from here that we have. I'll copy it, just put it here, and I guess here a break has been introduced. We'll replace this. So this seems to be okay, right? I'll simply copy this entire command and try to run it here. Seems to be okay. So let us see. Okay, so these are the sources which are already registered on the registry that we are looking for. So okay, so this is the registry that we are looking into. Okay, so now at this point, what I would like to check is the details of the contract address that we had given, right? So let us just check that. So if I go to the end of the list, this detail that we are able to see, okay, which has got registered, this one. So if you notice, we have the destination contact address starting with 51264. Okay, so this is not the one. I guess we have just moved ahead as log as such. Okay, so this is the one actually. Destination contact address, the last one actually. CE151. So this is nothing but our L1X flow contact. Let us check. So this is L1X flow contact CE151. So yes, this is the one, it has got registered. What is the source contact address starting with 3B819? So this is our Sepolia contact address starting with, remember we had removed 0x3B819, so it is the one, right? And apart from that, we have this source chain Sepolia event filters which we had registered, and the request was to create it, right? So which means our details of the source contract destination contact has got registered successfully. Now let us move on to the next step. Send the event. So now to send the event, what we are required to do is we will copy this code, go to our EVM-XCDP, right, scripts folder. Okay, and there we will add this send event.js file. So what we will do is, here I am just adding this file. This is done. We'll just add it here. So this seems to be okay. Now in this, what we need to ensure is two things. Here, we need to give our source contact address, and at this place, we are required to give our destination contact address. And the destination we have specified already to be BAC. So let us replace these details one by one. We'll start with the source contact address, which is of Sepolia. We'll copy this and replace it here. Similarly, we'll get the destination address, copy it and replace it here. So this is done. Seems to be okay, right? And after this, we will simply run it to send the event from Sepolia to BAC. So we should be able to see such a testnet transaction log if it runs successfully. So now we will go to our EVM project and try to run the command here. So the command related to it was the one that we had used as such for deploying the contact as well. So we'll use the same one, just changing the path. Okay. Okay, sorry, my mistake. We were referring to the other link that we had for hardhat, isn't it? Okay, so we'll be using this command. We will change the script name and the test network as such. We'll copy it. Here I'll give the name of our file, which is send event.js. If I'm not wrong, let us check that first. Okay, we have the file name as send event.js and the network that we have is Sepolia. So let us run this. So through this, Sepolia will be triggering a transaction to the L1x blockchain network, L1x Xtalk node as such, and from L1x Xtalk node, it would be triggered to the BSC testnet. So what would happen is the message that we are trying to send, hello world, would get reflected at both the places. So let us wait for this to get executed. So we get the deployer address, the wallet through which we are deploying, and the transaction. So this is the transaction hash as such that we have received. So there are two ways which we can verify this. So for this purpose, we go to our Sepolia testnet explorer. I'll simply refresh it because this is the wallet address we have, and it will the transaction would get reflected here. So is this the contact address that we are referring to? Let us just check. Okay, so it is showing the transaction, right, 44 seconds ago, and we can notice the transaction has. So if you notice, it is the same transaction hash starting with 0xv066 and ending with EFF. So it is starting with V066 ending with EFF. So this is the transaction that we are referring to, which has got initiated. And here we can go view input as in a UTF-8 format. So here you'll be able to see the message that we were trying to pass, the destination deployed contact address on the BSC testnet and the destination test network, which is BSC. It's not just hello world. You can send any message that you would be required to fulfill the business logic. So that is the beauty of it. Now to confirm whether this transaction has actually got initiated on the BSC testnet. So for that purpose, what we need to do is, remember initially Mohammed had explained that how it works. From Sepolia, it goes to the Xtalk node on L1x, and from Xtalk node, it is triggered onto the BSC testnet, that is the destination chain. So in this case, for the BSC testnet, Xtalk node is actually behaving as the source network. So for that purpose, we will be taking this gateway contact address as the address to check the transaction triggered on the BSC testnet. So let us check this. So if you notice, yes, 1 minute ago, the transaction has been triggered. We can go there and check the details to confirm. So these are the BSC testnet details. I'll click on show more details and view input as UTF-8 format. So if you notice, hello world message has been sent. Apart from that, you can go to the logs where you'll be able to see the topic which we had sent, right? Similarly on BSC testnet as well, we'll be able to see the same topic. Okay, so through this we can say that this has worked, executed properly. So in short, we are able to send XCDP message from a Sepolia network to a BC testnet. In the sense, we'll be able to pass any message using this cross-chain data and message passing protocol from any EVM-compatible chain to any other EVM-compatible chain. So this is it for today. Thank you so much for watching this video. We hope that you like it and follow the playlist related to Xtalk series. Thank you so much.